The purpose of this video is to explain the difference between angular velocity and tangential velocity. So in the previous video, we discussed that the tangential velocity, which is represented by v, is simply equivalent to 2 pi r over the period. So this means that it is a tangential velocity. So it is a velocity that, as if, the equivalent velocity in terms of a straight line, if this object is going in a straight line but instead it's going in a circle, so it means it's a circumference. What we have to do is take the circle and lay it straight. That is the equivalent of that velocity. So velocity is 2 pi r, which is the circumference, divided by the period, period of travel in one complete circle. Now, angular velocity is represented by the letter omega. So that's the angular velocity, which is the letter omega, Greek letter omega, which means you have to measure the angle inside the circle. So as this object is going around in this circular pattern, as it completes one complete circle, you want to measure the angle inside. So you measure the angle inside. So you measure the angle. For us, most of us would represent angle theta. And one complete revolution is 360 degrees. 360 degrees. That's the common measurement of angle that we are aware of. So we always use in class degrees. However, there is what we call radians. So now let's talk about radians. So omega is represented by, it's a representation of this equation, which is whatever angle inside one complete revolution divided by the period. Divided by our period. Now, the period for our angular velocity is the same as the period of your circular velocity, of your tangential velocity, because it's the same circle. It's the same path. It's the same object traveling at that moment. Now we just need to represent this. So we can say 360 degrees divided by the period. So that's degrees per second. However, in angular velocity, we don't use degrees, even though degrees is one of those common units that we use in everyday life, as I would describe it, or mathematical calculation, as we use it in calculators. But there is also another unit called radians. And the equivalent of radians is this. So for every 360 degrees, 360 degrees is equivalent to 2 pi radians. And if you go back to your original equation, which is 2 pi r over t from our tangential velocity, then it means all we need to do is to just remove the radius. Remove the radius, and that is 2 pi divided by t, or period. So here's the equation that we can use, and that is 2 pi over t. So this is the equation to use, which is our angular velocity. Let's use an example. Let's say the object is rotating. The object is rotate. If in this problem, let's say we have a radius. Just use some green markers. So let's say a radius r of 5 meters. and the object is or the object I've completed 10 revolutions. Okay, so 10 revolutions, or this one is revolving around. It's an object revolving around the circle patterns. So I would say 10 revolutions in 5 seconds. So 10 revolutions in 5 seconds. So how do we figure out? Let's solve for the tangential velocity as well as our angular velocity. So start with our tangential velocity. So let me just use a different color this time, so we can highlight some of our work. So let's solve for velocity, but for both of them we need to know our period first. So period, just like what I mentioned last time, we can actually use a modified version of period, which means that we just divide 5 seconds divided by the number of revolutions. And in this case, 5 divided by 10 is equivalent to 0.5 seconds. So 0.5 seconds. So therefore, this is your period. So if we proceed with tangential velocity, v, which is 2 pi multiplied by r divided by period. So let's proceed. So that's 2 pi multiplied by 5, which is our radius of 5 meters, divided by our period of 0.5 seconds. And our tangential velocity is simply equivalent to 62.8 meters per second. Okay, so emergency vehicles passing by. Sorry for that noise. And then let us solve for the next one, which is our omega, which is simply 2 pi over our period. 2 pi over our period. Okay. 2 pi over our period, which means that is 2 pi divided by the period of 0.5, and then our omega is simply 2 times 5 divided by 0.5. So here we have 12.57, and the unit is radians per second. So that will be our unit. So omega is simply 2 pi divided by the period. Velocity is 2 pi times the r multiplied by divided by our period. So that's a simple way on how to calculate omega and tangential velocity v. Or we can also establish a relationship. If you notice, something's missing here compared to this one. So basically, another way is to just use omega if you know the tangential velocity, which is v. All you have to do is divide it by our radius r. So that's a relationship. So all you have to do is to divide the velocity by r. So that will give us the omega. My warning though is to avoid using this relationship if you were given the radius, the period, because if you rely on this procedure, if your calculation on your tangential velocity is incorrect, or you made an error in calculating this answer, this value, and you just proceed by dividing it by 0.5, then it will give us the wrong answer for the second part. So it's still better to use the given instead of using a value that was calculated from the previous part of a problem. However, if we want to prove this, let's try, which is 62.8, and let's divide it by the 0.5, which divided by 5, which is our radius. And yes, it did give us the same answer, which is 12.56. I rounded it off to 57 in the solution when you use the value of pi, which is 3.1416, or more than 3.1416. Thank you, and hope this is helpful for us.